Welcome to my channel. Your tutor Mariam is here. It's the 46th video of Introductory Physics 1 and the 8th video. I'm going to talk about the laws of motion. That is the 5th subject of Introductory Physics 1. In this video, I'm going to talk about the normal force. What is the normal force? What is the relation between the normal force and weight? And at the end, I'm going to solve a couple of simple examples. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So the first question is, what is the normal force? Let's say I have a box standing on the table or on the ground and I want to figure out what is the normal force. I've already talked about the Newton's law. I'm going to put the link below. But here we need to know about the third Newton's law, which usually call it as action and reaction. So what Newton's law says is like if I have an object and the force applied to this object, there should be another force in the opposite direction, and the magnitude of that force must be equal to the magnitude of the force applied to that object if object is in the rest or move with a constant velocity. This is the third Newton's law, and with that I can also explain the normal force here. Let's say I have this box here which is at the rest, and then I'm gonna say there is a weight applying to this box, right? Because normally we solve the physics example while we assuming we are on the earth. So there is always the gravity force, and that gravity force W, I'm going to show it as W, is equal to m, mass of the box, times g is the acceleration, and we usually consider g as 9.8 or approximately 10 meter per second square, right? So that's that. This is my weight applying to this force. However, there is another force based on the third Newton's law that should be equal to the weight of the box. However, it must be in the opposite direction, right? So that my normal force going upward, and usually we show it with a symbol of n. So if I'm gonna show it in the Cartesian coordinate, then that's gonna be my x direction. That's gonna be in y direction. Weight gonna be downward, like here, W, and n must be in the opposite direction, which is positive. So my W is negative, my n gonna be positive. This is for the object which is at the rest, right? So this is the third Newton's law, right? Now let me talk about the second Newton's law. So based on the second Newton's law, my net force gonna be the sum of the force applying to the object, and that should be equal to mass of the object times acceleration, right? Now, if my object is at rest, then that means my acceleration is equal to 0, right? Because if it's not moving, then the velocity gonna be 0, so acceleration gonna be 0, right? So my net force F gonna be 0 here because my acceleration is 0 and then F gonna be 0. Let me show this as F, little f here, to not make you guys confused. Also, if my object moves with the constant velocity, then my acceleration again gonna be 0, right? Because if you remember, acceleration is equal to v2 minus v1 over t, right? So if it is moving with the constant velocity, that means my v1 equal to v2, right? That's the meaning of the constant velocity. So acceleration gonna be 0. So F, so that's gonna be the F equal to 0, right? Like a net force gonna be 0. Now let me find the normal force if object is at the rest or constant velocity. So with that, I have the normal velocity, which is positive, right? I have the weight of the object, which is negative, and then my object is at the rest or moving with the constant velocity, so the net force is gonna be 0, right? So with that, my N must be equal to W, right? So here is like my N equal to M times G, correct? That's how I can calculate the normal force. So there is a way I can increase or decrease the normal force, right? Let's see how we can do that. Now let's see how I can calculate the normal force if I apply the force downward to the box. It's like I'm pushing the box to the ground or table. So the forces I have here again gonna be the weight of the object, right? So I'm gonna have W, and again I'm gonna have the normal force in the opposite direction. So normal force is always upward, so it's like it's in the positive direction of x-axis. So I never ever write the normal force like that. It's totally wrong. It's always in the opposite direction of weight. So now I have three forces applying to this box. Let's go with the example of having the object at the rest again. So I'm going to start with the simplest example I can go. So again, based on the second Newton's law, my F, total F, gonna be the sum of the forces applied to this object. So I have normal force, which is N, minus W, and then this force I'm applying to the object has a negative direction as well, so that's gonna be F1, right? And object is at the rest, so acceleration, the total acceleration gonna be 0. So I'm looking for N, then N should be equal to W plus F1. So my W is mg plus F1, right? Let's say if my M is equal to 2 kilograms, I'm just assume some weight for this box. And then my N gonna be 2 times, I'm gonna say my acceleration is approximately 10 instead of going to 9.8, plus my F1 is 2 newtons. So my normal force gonna be 22 newtons, right? By the way, this is the symbol of normal force. That's the symbol of normal force. That's the unit for force. And here you can see normal force increase compared to the weight, because if I calculate weight here, my weight gonna be mg, right? So m is 2 kilograms, g is 10, and my weight is 20 newtons, right? This is the weight, and my normal force is 22. So that means my normal force is bigger than W, correct? So this is the way you can increase normal force. Let's see how I can decrease normal force. Let's calculate the normal force for this example. So again, my normal force gonna be upward. This is gonna be my N. My W gonna be downward. Object is still at the rest, so my F total gonna be 0, and that's gonna be equal to F1 plus N, because they both gonna be in the positive direction, minus W, right? So my F1 here gonna be 4. I don't know about my N, that's positive. And W, let's calculate the N. So N gonna be W minus 4. So my W is mg minus 4. This guy gonna be 2 times 10 minus 4, and it's gonna be 16 newtons, right? So now if I calculate W, is gonna be 2 times 10, so it's gonna be 20, and obviously my N is less than W, correct? This is for the object. If object is at the rest, right, or it's moving with the constant velocity, correct? Moving constant velocity, right? Now let's consider the example if box has the acceleration. Let me go back to the second example. So in the second example, force applied to the box, and it gives the box the acceleration of 2 meters per second square. Now I'm gonna find out the normal force. So again, my normal force gonna be upward, so that's gonna be my N. My W weight gonna be downward, and now I'm gonna write down the second Newton's law. Based on the second Newton's law, my F, total F, gonna be the sum of the F, forces applied to the object, and that's equal to m times acceleration, right? So the total force gonna be N minus W minus F1 equal to ma, right? Because that time my acceleration is not 0. So my N is equal to W plus F1 plus ma, correct? So my W is m times g. My F1 is 2 newtons. And then this is gonna be m times acceleration, which is 2. So let's substitute the numbers. Let's say the mass of this box is 2 times 10 plus 2 plus, it's gonna be 2 times 2, right? And that's gonna be 26 newtons, right? What about the third example? So here I have a force applying upward. So again, my normal force gonna be upward, weight gonna be downward, and then my net force gonna be F1 plus N minus W, correct? And that's gonna be m times acceleration. So let's substitute the number. My F1 is 2 newtons plus, I don't know about N, my W gonna be m times g, which is 2 times 10, right, equal to 2. So my acceleration is also 2. So then that's gonna be 2 plus N minus 20 equal to 4. So with that, my N is equal to 22 for this example. So here I have a question for you. What happens if object move horizontally with the acceleration of 2 meters per second square? So what's going to happen for the normal force? Can you calculate the normal force for this example? Think about it and leave the comment below. What do you think about this example? And if you find the answer, feel free to write down the answer. And in the next video, you're gonna find out how to solve this example. I hope this video helped you to understand what is the normal force, how you can calculate the normal force. If you like my video, hit the like button, and I'll see you in the next video. Force